Ever wonder why we need software testing? Well, let's dive into that. Software testing is like the backbone of software development. It's like the safety net of a trapeze artist, ensuring they can perform without fear of fatal error. It's crucial in spotting those sneaky bugs and errors that can pop up in the code like unwelcome party crashers. But it's not just about finding faults, it's about improving performance. Just like an athlete training for the Olympics, software needs to be tested and retested to ensure it's running at its peak. It's about making sure the software can handle what's thrown at it and still perform well. Moreover, it's about trust. Trust from your users that your software won't fail them when they need it most. Without software testing, we risk delivering a product full of bugs and errors, and no one wants to be the bearer of a flawed gift, do they? So, what makes a good test? Let's dig into the defining characteristics of high-quality software testing. Firstly, good tests verify the correctness of the code. They ensure that your software is functioning as anticipated, catching any errors or bugs that may have slipped through the development process. Secondly, good tests help prevent regression. They safeguard your software from unexpected changes or issues that could arise due to modifications in the codebase. This means that new features or updates won't disrupt the functionality of your existing system. Next, good tests define the boundaries of your system. They outline what your software can and cannot do, setting clear expectations for its performance and behavior. Good tests also act as executable pieces of documentation that are always current. Unlike a wiki or SharePoint, they provide an up-to-date and reliable source of information about your system's functionality. Moreover, good tests guide design choices toward simplicity. They encourage developers to create clear and straightforward code, making the software easier to understand and maintain. Good tests also allow for continuous releases with confidence. They provide assurance that your software is ready for deployment, reducing the risk of post-release issues or user dissatisfaction. Furthermore, good tests enable you to cope with change. They ensure that your software remains robust and adaptable, even as it evolves and grows over time. Good tests also help to stabilize your codebase. If a change is made in a method without altering the test, then one or more of your tests should alert you by failing. Finally, good tests deal with the past, the present, and the future. They validate your software's current functionality, while also preparing it for future developments and changes. In essence, good tests are not just about checking the code, they are about ensuring the software meets the needs of the user. A well-crafted test suite is a powerful tool that boosts the quality of your software, provides valuable insights for your development team, and ultimately leads to a better user experience. So remember, when it comes to software testing, quality truly matters. Now, let's flip the coin. What makes a test poor? Firstly, poor tests are brittle. They break easily, even with the slightest change in the software's environment or functionality. This makes them unreliable and a burden to maintain. Secondly, they are complex. A good test is simple and straightforward, focusing on one aspect of the system at a time. However, poor tests try to cover too much at once, making them difficult to understand and work with. Thirdly, poor tests are hard to maintain. They often require constant tweaks and updates to keep up with the evolving software. This not only consumes valuable time and resources, but also introduces the risk of errors and inconsistencies. In addition, poor tests are cryptic. They lack clear and concise documentation, leaving developers puzzled about their purpose and expected outcomes. This opacity can lead to misinterpretation, misuse, and even disregard of the tests. Another characteristic of poor tests is their slowness. They take an unnecessarily long time to run, slowing down the entire development process. Time is a precious commodity in software development, and tests that waste it are a liability. Moreover, poor tests do not guide or document anything. Unlike good tests that serve as living documentation and guideposts for design decisions, poor tests provide no such value. They exist merely as procedures to be followed, not tools to be leveraged. Lastly, poor tests deal with the past and the present only. They fail to consider future scenarios and potential changes in the software. This short-sightedness makes them less effective in ensuring the software's long-term reliability and adaptability. In essence, poor tests can cause more harm than good, leading to false confidence and overlooked bugs. They are like a faulty compass, pointing you in the wrong direction and leaving you lost in the vast sea of software development. So, strive for good tests that are robust, simple, maintainable, clear, fast, informative, and forward-looking. They are your reliable guide to creating high-quality software. How can you tell if your tests are good or poor? Well, one telltale sign is if you find yourself skipping some tests because they're cumbersome or slow. This is a red flag that your tests may be leaning towards the poor side. Good tests are designed to be integral to the development process, not a hindrance. They should be efficient, clear, and easy to maintain, allowing you to verify the correctness of your code swiftly and effectively. If you're constantly bypassing certain tests, consider revising them. Perhaps they're too complex, or maybe they're not accurately reflecting the behavior of your system. Remember, your tests should guide your design choices towards simplicity and clarity. They should act as executable pieces of documentation that are always current, helping you to cope with changes and evolve your software at a steady pace. Your tests should be a tool, not a burden. It's time to address this. Tests are more important than the code itself. A bold statement, but let's unpack it. Picture this. You wake up one day and find that your entire codebase has mysteriously vanished. Panic ensues, undoubtedly, but then you remember you still have your tests. Suddenly, the situation appears less dire. Why? Because tests are a blueprint of your code. They encapsulate the functionality of your software, detailing what each part of your code is supposed to do. With your tests as your guide, you can recreate the gist of your codebase, one test at a time. Sure, the exact implementation might be different, but the functionality will be the same. But here's the kicker. Tests are not just about verifying code implementation. They're also about understanding the behavior of the system. If you think about it, when users interact with your software, they don't care about the code behind the scenes. What they care about is the behavior of the system. Does it do what they expect? Does it do it efficiently and reliably? When you're testing, you're not just checking if your code works as intended. You're also verifying that the system behaves as expected. You're making sure that when a user clicks a button, the right action takes place. You're ensuring that the user experience is smooth, intuitive, and free of bugs. This is why testing is so crucial. It's a way to step into your user's shoes and see your software from their perspective. It's a way to catch any discrepancies between what you think your software does and what it actually does. So when you're writing your tests, don't just focus on the code, focus on the behavior. Ask yourself, what should happen when this piece of code runs? How should the system react? What should the user experience be like? Remember, good tests are like a safety net. They catch errors before they reach the user, allowing you to fix them in a controlled environment. They help you understand your software better, and they guide you in improving it. Good testing is about more than code. It's about understanding and improving the system as a whole. Want to improve your testing? Here are some tips. First, follow the given when then structure, also known as arrange, act, assert. This straightforward approach makes your tests more readable and easier to follow. You start by setting up the conditions, then you perform the action, and finally, you verify the outcome. It's simple, yet effective. The second tip is about who writes your tests. Only let trusted software developers handle this task. After all, your tests are as important as your code, and you wouldn't let just anyone modify your codebase, would you? Lastly, avoid abstractions. The closer your test is to the system under test, the better. Say no to using abstractions like cucumber, gherkin, and the like. Why? Because you end up spending twice as much time writing tests that are harder to maintain. With these tips, your testing can become a powerful tool in your development process. We've covered a lot today, haven't we? In the vast landscape of software development, we've navigated the terrain of software testing, understanding why it's not just a necessity, but a cornerstone of building robust, efficient, and reliable software. We've discovered the hallmarks of good tests, those that verify correctness, prevent regression, guide design, and ultimately, allow us to release with confidence. We've also delved into the dark side of poor tests, the ones that are brittle, complex, slow, and fail to guide or document. We've explored how to identify the quality of your tests, and learned that if you find yourself skipping tests because they're cumbersome or slow, you may be veering towards the poor test territory. We've emphasized that tests are more important than the code itself, as they encapsulate the code's essence. We've shared tips for good testing, like adhering to the given when then structure and avoiding unnecessary abstractions. Now, it's over to you. Good luck and happy coding.